delay. All right. So, like I was saying, we are looking at the chemical bonding, and yes, on Monday we started with electronic and electrovalent and ionic bonding, whereby we said that atoms that are electrons are usually involved in any chemical bond, and these electrons can be shared, gained, or lost. And last lecture was majorly for the transfer of electrons, either by gain of electrons or loss of electrons between metals and non-metals. And one of you asked the question, what happens to elements in groups 4 and 5? And I said that will take us to the next lecture. So today we are looking at covalent and coordinate covalent bonding. So a covalent bond is defined as the force of attraction that arises due to mutual sharing of electrons between two atoms in a molecule. So when you have a molecule or a compound, the atoms that are linked together as a result of the sharing of electrons between the two atoms is referred to as covalent bonding. Don't forget, ionic and electrovalent bonding arise as a result of transfer of electrons between two atoms, usually a metal and a non-metal, between an electropositive element and an electronegative element. So there's a transfer of electrons. But for covalent bonding, there's a mutual sharing of electrons between two atoms. The mutual sharing of electrons between two atoms. Please don't write in your attendance. Please don't sign in to the class. Don't get me distracted by the chat. The only thing I want to see in the chat is your question. But by the time you write attendance, put your name in this, I will be able to identify if there's any question. So please don't type in your name and your matric number or department. Nobody is taking attendance, please. If you clog the chat room with a lot of names and attendance, I will not be able to know if any question comes in. Let the chat room be dedicated solely for questions. Thank you very much. So don't sign in, nobody will penalize you. So as I was saying, the atoms combine by the sharing of electrons. And the electrons they share, they don't share one electron, they share these electrons in pairs. Just like you have a pair of socks, two pieces of socks make a pair of socks, two lenses make a pair of glasses. So two pairs of a pair of electrons, two electrons make one pair of electrons. So combining atoms can share one pair of electrons, whereby each atom will donate one electron each, or two pairs of electrons, where each atom, the two of them will bring two electrons, or they could share three pairs of electrons. So that is what will now give rise to the bonding that we see. So when the atoms and the sharing of these electrons, the mutual sharing, is also based on the rules that we have talked about before. That is the octet rule. That means that every atom, when they share this electron, they want to attain the stable configuration of the nearest noble gas. So if in their sharing, they still have 8 electrons to form a duplex, or to form an octet, or 2 electrons to form a duet in the case of elements like hydrogen. Hydrogen can never form an octet because hydrogen has 1 electron, and by the time it shares with another 1 atom, the maximum it can have is 2, and that is what gives rise to a duet. And as you can see beneath, we have a molecule of water, H2O, 2 atoms of hydrogen and 1 atom of oxygen. Oxygen, as we know before, the oxygen has 6 valence electrons. Oxygen has 6 valence electrons originally in its neutral state. And for oxygen to be happy, oxygen needs 2 electrons to make the octets of the valence shell. Naturally, oxygen has one. Hydrogen has one electron. This hydrogen also has one. And but for hydrogen to be happy, hydrogen needs one more electron. Hydrogen needs one more electron, and that is why hydrogen will readily look for one electron to form a duplet. So if you look here now, hydrogen has one originally, and when it shares with oxygen, one of the 6 electrons with oxygen, hydrogen becomes a duplet, a duet. The second hydrogen also becomes a duet, and each of these hydrogen bring one electron. So you could see here now that the electrons that you have here, this particular electron here, let me annotate, the electron here is from hydrogen. This electron here is from this hydrogen. And these other electrons, the other 6, this 1, 2, 3, 4, 5, 6, they are from oxygen, the 6 valence electrons of oxygen. This one here is the valence electron from one hydrogen. This one here is the valence electron from this other one hydrogen. So hydrogen can pick one of these electrons and share with hydrogen and with this oxygen. So this will form a duet. This other hydrogen will pick one electron and form a pair. And these 2 other ones are just the non-bonding electrons. So these 6 electrons of oxygen, 2 of them are being shared with hydrogen to form a pair. So that is how the duplet of the formation of bond takes place. So now, going forward, so what are the key characteristics of covalent bonding? Number 1, it involves electron sharing. It involves electron sharing. And another key characteristic is that it usually occurs between 2 non-metals. It occurs between 2 non-metals. And that is why our groups 4 and group 5 elements can easily form covalent bond. And in the previous example, you see now hydrogen is a non-metal, oxygen is a non-metal, so they can easily form covalent bond. I've told you, please don't sign attendance. I've told you, only questions. It's only questions that you should put in the chat box, please. Only questions in the chat box. Don't sign any attendance. So and whenever this happens, they form molecular compounds. You know, for electrovalent compounds, they usually form ionic compounds between sodium and chlorine. Sodium ion, chlorine ion will form an ionic compound. But for covalent compounds, they form molecular compounds. And now this happens is that the nuclei, the 2 nuclei of the 2 atoms will attract the same shared electrons to form a covalent bond. So the orbitals that contain the valence electrons will now overlap. Our atom A has its electrons in the orbitals of the valence shell. The atom B also has the valence electrons in another orbital. These 2 orbitals can now overlap and now give us a common orbital. So they now share a common orbital. As you can see in the previous example, you can see that there's an overlap. The valence electron of hydrogen are in blue circle, while that of oxygen is the red circle. And you can see an overlap. At this overlapping point, these 2 electrons there do not solely belong to hydrogen, neither do these 2 electrons belong solely to oxygen, but they are sharing it. So when you go through the blue circle, you count 2 electrons for hydrogen. Go through this blue circle, you get 2 electrons for the other hydrogen. And if you go through this red circle, you count 8 electrons for oxygen. So there's an overlap. So these are the overlap of the 2 orbitals. So in molecular bonds, in covalent bonds, the orbitals will overlap to create a common orbital. At that orbital, at that point where they overlap, that is where the bonding takes place. So these electrons are shared by the nucleus of both atoms. So atom A has its electrons, Atom B has its own valence electrons, and when they are sharing, the orbitals where these valence electrons reside will overlap to create a common orbital. So covalent compounds are formed due to the covalent bonding, and so the compounds formed are called covalent compounds. And the number of electrons that an atom will donate or will contribute for the mutual sharing whenever the bond is going to be formed is called the covalency of that compound. So if you have each of them having one atom and one electron, the covalency of the electron they are sharing will be 1. If they are sharing 2 electrons, the covalency will be 2. If they are sharing three electrons, the covalency will be 3. So if you look at the example we have here now, the previous example we have there, you can see that the covalency here is 1 because they are sharing. Remember I said a pair of electrons we are talking about is 2 electrons. 2 electrons make a pair. So when you have, just like you have a pair of glasses, 2 lenses make 1 pair. So 2 electrons here are being shared, and that is 1 pair. And if you look at the way electrons are formed, let's say you have atom A. This is atom A. You have atom B. And between the two of them, between the 2 atoms, you have a bond. So this is a bond between atom A and B. So meaning that what this tells us is that atom A has an electron. Atom B also has its own electron. So when they are now sharing their electrons, they share it in such a way that A does not have the electron anymore to itself. B also does not have the electron to itself. The 2 of them are now sharing, and when they share, a bond will be formed between them. So and when they are sharing a pair of electrons, that is, the covalency will be 1. So assuming they now share 2 electrons, 2 pairs of electrons, B is bringing 2 electrons, and A is also bringing 2 electrons, the covalency will be 2. If they are sharing 3 electrons, the covalency will be 3. So let's continue. So now, looking at hydrogen atom, for example, you can see that hydrogen has 1 valence electron. The atomic number of hydrogen is 1, so it has 1 valence electron. So when 2 hydrogen atoms come together, hydrogen cannot form an octet because it has only 1. The nearest noble gas configuration it will want to attain is that of helium, which are with 2 electrons. So helium has a duplet. Helium has 2 electrons. So when you look at this now, hydrogen comes with 1 electron, the other hydrogen comes with 1 electron, and they share. Okay, let's share this one. And when they share, the 2 of them now have a bond between them. And you can now see that the bond between the 2 hydrogen atoms will just be 1 single bond. So 1 bond between them. Let me try and put the bond in between them. So now between these 2 hydrogen atoms, you now have a bond. So this bond, as it were, is as a result of the electrons that are being shared. So this hydrogen has 1 electron. This other hydrogen has 1 electron. So the 2 electrons that they have in their valence shell are now being shared. And as you can see here, the electrons are now shared between them. So there's an overlap. See, this electron is in an orbital. This other electron is in an orbital. And when the 2 of them come together, there's an overlap of this orbital and now have a bond between the 2 hydrogen atoms. So that is what makes it. So the covalency of this, as you can see, is 1 because they are sharing 1 pair of electrons. So let's look at the types of electrons that are available in covalent bonding. And before I go forward, let's look at, for oxygen, for example, oxygen as an example now. Okay, we'll look at that later. So now let's look at the types of electrons that we have in covalent bonding. We have 2 types of electron in covalent bonding. The first category are called the bonding electrons. And these electrons are the pairs of the valence electrons that are involved in the covalent bond formation. We call them bonding electrons. Where we have the other types of electrons that are also valence electrons. These two electrons are valence electrons, but one of them, of these valence electrons, a particular group of them are involved in bonding. So we call them bonding electrons. Then the pairs of valence electrons that are not involved in electron share in bonding, they are the ones we call the non-bonding electrons, or what we also call the lone pairs of electrons. Non-bonding electrons on lone pair of electrons. So they are not involved in electron sharing. They are not involved in bond formation. So let's still look at our example of water. Remember, for water, we said that in this particular example, the hydrogen has its own duplet. The other hydrogen has a duplet. And the oxygen now, it must be an octet. So you see 8 electrons surrounding the oxygen. 8 electrons surrounding oxygen. So looking at this now, you will see that the 2 electrons that are involved in bonding are these 2 electrons. So these are the bonding electrons, as it were. These are the bonding electrons. This one, these 2 are the, so this is a pair of bonding electrons. These other 2 are a pair of bonding electrons. So the bonding electrons we are talking about are these. The electrons that are involved in bond formation. If you look at water, is H2O. So you have H, your hydrogen atoms are here. The other hydrogen atoms are here. So, and you have the lone pairs of electrons. So this oxygen has 2 lone pairs of electrons. There's this electrons here. These 2 electrons are here. These other 2 electrons are here. So you see there's another electron here. There's another electron here, making the 6 valence electrons of oxygen. Then we have hydrogen has its own electron, 1 electron. Or let me use another color for the electron on. Let me look for. So let's look at. So here now we have the electrons. So these are the electrons for hydrogen. So hydrogen has 1 electron. So if you look at it now, this 2 electrons here, the electrons there are the bonding electrons. So these 2 here are the bonding electrons, and these other 2 pairs of electrons are the non-bonding electron pairs. So now in water, we can say that water has 2 pairs of non-bonding electrons. This is 1 pair, this is 1 pair. And it has another pair of bonding electron that bonds it with hydrogen. So that is how we get our bonding electrons and the non-bonding electron. And the non-bonding electrons are also referred to as what we call lone pair of electrons. So in water, for example, if I ask you now, you can type it in the chat box. How many non-bonding electrons does water have? Put it in the chat box. How many bonding electrons does water have? How many bonding electron? How many pairs? 2. Yes, water has 2 pairs. What about non-bonding? What about bonding electrons? So it is not 4 non-bonding electrons. Water has 2 bonding pairs and 2 non-bonding pairs. That's good. Thank you. Stop typing. Thank you. 2 pairs of bonding and 2 pairs of non-bonding. 2 pairs of bonding. Thank you. Thank you. So you can see here that water has 2 pairs of bonding and 2 pairs of non-bonding. So that's how you know bonding and non-bonding pair. Let's look at more examples. Look at hydrogen that we said before. Hydrogen has 1 electron each. And when they come together to form a covalent bond, each atom will attain noble gas configuration, and the noble gas configuration, which noble gas configuration will hydrogen attain? Which noble gas configuration will hydrogen attain? You can type in the chat box. Helium, that's good. So helium has 2. So hydrogen will attain the configuration of helium. And that is when this would now make a pair. So between these 2 hydrogen atoms, we have 1 pair of electrons. Let's look at fluorine molecule. Fluorine molecule is made up of 2 fluorine atoms. Each fluorine atom has 7 valence electrons. So, but fluorine, to be happy, there is one of them now that is not paired. So this 1 electron here can form a covalent bond with 1 electron in the other fluorine. And so these 2 of them, they can share this electron. So now for fluorine, you can put in the chat box how many bonding electrons does fluorine have? Fluorine molecule. Bonding electrons, how many pairs? 1. What about non-bonding? Non-bonding. Non-bonding. 3. Not 6. Instead of you writing 6, I'm asking of pairs. Electron work in pairs. There are 6 non-bond, but in terms of pairs, 3 pairs of non-bonding electrons and 1 pair of bonding electron. Thank you very much. So the non-bonding electron or the lone pairs are 3, and the bonding pair is 1. Then let's look at hydrogen fluoride. So hydrogen fluoride will also have how many non-bonding electron? So let's look back at fluorine. Fluorine molecule has how many bonding pair of electrons? Fluorine molecule. Fluorine molecule, this one, how many bonding pair of non-bonding pair of electrons? Non-bonding, non-bonding, non-bonding. It is not 3, oh. It is 6. Let's count. 1, 2, 3, 4, 5, 6. 6 non-bonding pairs. We are not looking at an individual. We are looking at a molecule. Not 3 pairs, Mohammed. It is 6 pairs. Each fluorine has 3 non-bonding. And when the 2 fluorine atoms come together, it makes 6. Hello? It makes 6. Can you see? Let's count together. 1, 2, 3, 4, 5, 6. The molecule, we are talking about fluorine molecule, not fluorine atom. So the molecule has 6. And the non-bonding is what? 1. 1 bonding and 6 non-bonding pairs. 6 pairs. And the pairs come in 2s. So in this fluorine now you have 1, 2, 3, 4, 5, 6. 6 non-bonding pair in fluorine molecule. And the bonding pair is 1. Now let's look at hydrogen fluoride. How many bonding pairs do we have? Bonding pair in hydrogen fluoride? 1. What about the non-bonding pair? Non-bonding pair in hydrogen fluoride? 3 pairs of non-bonding pair. Thank you very much. I can see you are now understanding and getting the gist. Thank you very much. So now let's continue. So what are the characteristics of covalent bond? Their mode of formation is the characteristics. The characteristic here is that the covalent bonds are formed as a result of mutual sharing of 1 or more pairs of electrons. Let's look at a quick example we have on the board, on the slide. For chlorine, how many pairs of electrons are they sharing? Chlorine molecule. How many electrons? Sonny is asking how the HF bonding pair is counted. This is simple now. Go back, let's go back to our hydrogen fluoride. Hydrogen has 1 valence electron. Fluorine has 7. Hydrogen needs to be happy. It needs just to share with 1 and make a duplet. Fluorine also needs to just share with this one and make an octet. And so when they come together, hydrogen will share 1 with this one of fluorine. So fluorine had 7 originally. So we will share this one with hydrogen to make 8. And if you look at it here, let me annotate it. If you look at it here now, hydrogen is now having a duplet. and fluorine is having an octet. Fluorine is having an octet. This is your fluorine now. Let me clear this. Okay, all this. Let me go back. Hydrogen is having a duplet. It has its own one electron and is sharing one with fluorine. And fluorine also has its own orbital. So you can see now that there is an overlap. So where the overlap is where this bond is formed. And fluorine, this 1, 2, 3, 4, 5, 6, these 3 pairs of electrons, 1, 2, 3, they are not involved in any bond. So these are the 3 here, 1, 2, 3. And the one here is the one that has overlapped to form a bond. I hope that person asked the question now understands. So let's continue with the characteristics. So we said that the electrons are formed as the result of mutual sharing. And I asked the question for the molecule we have here. How many bonding electron pair do we have between chlorine molecule? For chlorine molecule, how many bonding electron pair? 1 pair. What about non-bonding electron pair? Non-bonding for chlorine. 6, correct, 6 non-bonding. You can count them. 1, you can count 1, 2, 3, 4, 5, 6. These ones are not involved in any bond. The only one involved in the bond formation there are these 2. This is the one involved in bond formation. So these are the bonding pair, while the others are not. Let's look at oxygen. How many bonding pair do we have in oxygen? For oxygen, 2 bonding pair. You can see 1, 2 bonding pair. And what about the non-bonding pair on the oxygen molecule? 4 non-bonding pair, correct. Let's look at nitrogen. So nitrogen has, I would rather write my nitrogen like this, so I will not be confused. N. So for nitrogen, we have 1, 2, 1, 2, 1, 2. And we have the non-bonding electron on each of them. So for nitrogen, how many bonding pairs do we have? We have 3 bonding pairs for nitrogen. What about the non-bonding pairs? 2 non-bonding pairs, correct. So you now understand the gist of how we get the bonding pairs and the non-bonding pairs. So we can have a single bond. So when you have 1 pair, you give a single bond. So between chlorine and chlorine, there is a single bond. If you have 2 bonding pairs, you have a double bond. If you have 3 bonding pairs, you have a triple bond. So what is the covalency for oxygen now? Covalency of oxygen is what? Covalency of oxygen. You can type it in the chat box. What's the covalency of oxygen? 2. What about the covalency for nitrogen? Nitrogen, 3. What's the covalency for fluorine? Fluorine covalency for fluorine, 1. Chlorine, 1. Thank you very much. So that is how we get our covalency. Now we have the directional character. Another characteristic is the directional character of these bonds. Covalent bonds are directional in nature. Remember we said for ionic bonds, they are non-directional, but covalent bonds are directional in nature. And the reason is that the electrons that are shared are delocalized. They are localized in a particular space between the nuclei of 2 atoms. So for example, now, the bonds that are going to be shared there are these 2 electron pairs, not this one. So they are directional. That is what we mean by the directionality of this. The person that is asking for covalency, but he said covalency is number of electron pairs that are shared. So if you share 1 electron pair, covalency is 1. If you share 2 electron pairs, covalency is 2. If you share 3 electron pairs, covalency is 3. Listen very well. Don't just be asking unreasonable questions. Covalency is the number of electron pairs that are shared. That is what covalence, and I've already explained that. VSEPR will come back, we'll be discussing this in subsequent lectures. So the electrons are localized in space. So what we mean by localization is that when you have electrons, for example, for oxygen, your oxygen atom, if it has 6 valence, let's say this is your oxygen, it has 6 valence electrons, 1, 2, 3, 4, 5, 6. So if there's going to be any sharing of electrons at all with any to form any bond, the ones that will be available for sharing are these ones that are singly occupied. These double ones that are already formed, they will not be involved any sharing because they already formed a pair. So it's these single ones that are not in any pair that are available to form bond and share with others. So that is why it is direction. They have a definite space where they occupy. That is what we mean by the directional character of bond formation. Then also so this gives the directional character of covalent bond, and this is what the other types of bond, which is ionic, they don't have this characteristic. So another term that we also need to know is what we call bond order. And bond order is the number of electron pairs that are shared between two atoms. So if I may ask you, what is the bond order for nitrogen molecule? What is the bond order for nitrogen molecule? Bond order for 3. Correct. Because nitrogen molecule will have, there are 3 bonds that are shared between 2 nitrogen atoms, the nitrogen molecule. So the bond order for nitrogen molecule will be 3. While that of oxygen will be what? What will be the bond order for oxygen? Oxygen will be 2 because, so bond order is the same thing as covalency. So the covalency of nitrogen is 3 and it has a bond order of 3 and it's having 3 pairs of electrons. The covalency of oxygen molecule is 2. It has a bond order of 2 and is sharing 2 pairs of electrons. Now for hydrogen, what is the bond order for hydrogen? Hydrogen molecule, the bond order will be 1 because it is sharing just 1 pair of electrons. The bond order of hydrogen will be 1 because it's sharing 1 pair of electrons. Thank you. So now let's look at bond length. The bond length now is the minimum distance, energy distance between the nuclei of 2 bonded atoms in a molecule. Bond order is the same thing as covalency, yes, and the same thing as number of bonded electron pairs. So the bond length is the minimum energy distance between the nuclei of 2 bonded atoms in a molecule. So the minimum energy distance. So the distance, the bond length is the minimum of energy distance between the nuclei of 2 bonded atoms in a molecule. So let's continue. So now, let's look at the single covalent bond. Single covalent bond has a covalency of 1 and is the sharing 1 pair of electrons between the 2 atoms. So in this case now, for single covalent bond, what you have is one single line. One single line tells us that it is the covalent bond. It has 1 pair of electrons. And this is what we've done before. Each hydrogen atom has 1 electron. The 2 electrons are overlapped to give us the configuration of helium. And you now have a single bond. So the bond order for this is 1. Bond order for single covalent bond is 1. Now let's move to the another example. We have water, for example. Oxygen, 1 oxygen atom and 2 hydrogen atoms. Here, each hydrogen atom has 1 electron and the oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. And of these 6, only 2 will form covalent bonds and share with hydrogen. So this oxygen shares this 1 atom here, and 1 electron here shares with 1 electron of hydrogen. This other 1 electron shares with 1 hydrogen electron. So that is why you now have your bond formation as shown. So you have this now. This is the bond between your hydrogen atom. So this hydrogen atom is having This hydrogen atom is having an electron. This is an orbital complete, a duplet. This hydrogen also has a duplet. And so the oxygen also forms an octet, as you can see. So there's an overlap of these two bonding pairs. So these are the ones that you have the bond here. So this is one bond here. This is a bond is formed here. Another bond is also formed here. So that gives us the electron, the formation of the bond between, and here, these two electron pairs that are here are not involved in bonding. So oxygen now, the 6 valence electrons, the oxygen now has an octet, 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen also has 1, 2, 1, 2. So each of them have attained noble gas configuration, and you now have a single bond between hydrogen and oxygen and another single bond between hydrogen and oxygen. Covalency of oxygen is not 2. Covalency of oxygen molecule. You cannot talk of covalency of an atom. You only talk of covalency of a molecule. So it's only, you only get covalency when two hydrogen and oxygen atoms come together to give a double bond between them. So in this case now, we are talking of the covalency of water now. And we are talking of the covalency between oxygen and hydrogen and another oxygen and hydrogen. So in this case now, water has a covalency of 2. And the 2 covalencies as a result of 1, the bond, oxygen and hydrogen has a covalency of 1. This oxygen and hydrogen has another covalency of 1. You only talk of covalency between 2 atoms, not a single atom. Note that. So let's look at ammonia. Ammonia is formed as a result of the bonds between 1 nitrogen atom and 3 hydrogen atoms. If you look at the configuration of nitrogen, it's 1s2, 2s2, 2p3. So nitrogen has 5 valence electrons. Hydrogen has just 1 valence electron. So for nitrogen to be happy, it needs 3 more electrons to form an octet. And in doing this, nitrogen will say, don't worry, let me bring 3 hydrogen atoms to come and play with you. And each hydrogen atom comes with 1 valence electron. As you can see, the dot here represents the electron of hydrogen, and the cross represents the electron of nitrogen. So nitrogen has 1, 2, 3, 4, 5. And remember I told you when we're talking about Lewis structures that you first arrange your atoms singly before you pair them up. So nitrogen will have 1, 2, 3, 4, 5. So you have a pair and 3 single atoms. So these 5 electrons you're having here, there is a pair, as you can see, the pair, and 3 single ones. So it's these 3 single ones that will now form covalent bonds with 3 hydrogen atoms. So the hydrogen has a dot, and a dot. So at the end of the day, you now have your hydrogen having a duplet, each of the hydrogen atoms having a duplet. The other hydrogen atom also has a duplet, and your hydrogen and your nitrogen now is an octet. So you can see nitrogen now has an octet, 8 electrons for nitrogen. So that is how you get. So for this now, the covalency of ammonia is not 3. I told you you can't get a covalent, you only use covalency between 2 atoms. So between each of the nitrogen-hydrogen bond, you have a covalency of 1. So there's a covalency of 1 between nitrogen and hydrogen, another covalency of 1 between nitrogen and hydrogen, another covalency of 1 between nitrogen and hydrogen. So here, how many lone pairs of electrons do we have for ammonia? How many lone pairs of electrons for ammonia? 1 pair, thank you. Then, how many bonded pairs of electrons do we have in ammonia? Bonded pairs, 3. So we have 3 bonded pairs, 3 bonded pairs, 1, 2, 3. And we have 1 lone pair that is not involved in bond formation. So these two electrons, this 1 pair this pair of electrons is not involved. Ammonia does not have a covalency of 3. Ammonia does not have a covalency of 1. Covalency is only between atoms. So you want to describe ammonia now, it has a covalency of 1 between one nitrogen. Don't put your name. I'm not interested in your name and your department. I've told you I'm not interested in your name and attendance. I'm only using the chat box to ask questions from you. Those of you writing your names, don't listen to simple instructions. So now, between nitrogen and hydrogen, there is a covalency of 1. Between this nitrogen and nitrogen, there's a covalency of 1. Between nitrogen and nitrogen, there's a Adeyemi Kuwamo, what is your name? Can't you listen to simple instructions? Nobody is interested in your name and your matric number. So we have 3 bonded pairs in ammonia and 1 lone pair of electron in ammonia. Covalency is not, for covalency, we rather use covalency between, you can see the way we use covalency here, where between the diatomic molecules. And the example I gave here before, these are diatomic molecules. You can see here now, hydrogen is diatomic, the same hydrogen atom. Oxygen is diatomic, nitrogen is diatomic. So you can use that. So, but it's the same covalency in this molecule is the same thing as the number, the bond order. So you only talk of covalency of the bond, the particular bond is, remember, what's the definition for covalency? The definition for covalency is the number of electrons an atom contributes towards the mutual sharing. So you only talk of covalency between 2 atoms. But when you have a molecule like ammonia that has 4 atoms, you can't talk of covalency. You can only talk of covalency between 2 particular atoms that form a bond in a particular molecule. Covalency does not occur between only 2 atoms. Yes, look at the formula and the definition. Definition says that the number of electrons which an atom contributes towards mutual sharing, towards the formation of a bond. So covalency is between 2 atoms. Covalency is for 2 atoms, but you can define covalency of a covalency in a molecule. Like for example, in ammonia, the covalency between nitrogen and hydrogen is 1. But in a molecule, for example, if you have only 2 atoms in a molecule, the covalency is the same thing as the number of bonded pairs of electrons. We will not finish this class today with these all your questions you are asking. So this is ammonia, like we have said before. So the unshared pair of electrons on the nitrogen atom that we have here is called the lone pair of electron or non-bonding pair of electron. And these other 3, and it is not involved in any bond formation. So the lone pair of electron does not take part in bond formation. So that's why it is called the non-bonding pair. So another name for lone pair of electron is non-bonding pair of electrons. So this electron here is not involved in bonding. The ones that are involved in bonding are these 3 pairs of bonded electrons. So for double covalent bond, it is the bond formed between 2 atoms due to the sharing of 2 electron pairs. So when 2 electron pairs are shared, yes, non-bonding pair means lone pair. So when 2 electron pairs are shared, a double bond will be the result. Let's look at oxygen molecule. So you have 2 electron pairs shared. And even like CO2 also here, there are 2 electron pairs also shared here. So between this carbon and oxygen, 2 electron pairs. Between this carbon and oxygen, there are 2 electron pairs shared. And in terms of strength, the strength of the bond, a double bond is twice stronger than a single bond. That is why it's easy to break a single bond, but not easy to break a double bond. A double bond is not easily broken, but a single bond can be easily broken. And for this now, the bond order between oxygen atom two oxygen atoms in oxygen molecule is the bond order here is 2. The covalency is 2. And here between these two atoms there, the covalency is 2, the bond order is 2, and you have 2 electron pairs that are shared between them. So let's look at an example of CO2. Look at this now. Oxygen has 6 valence electrons as shown in the black dots. The oxygen has 6 valence electrons in the Lewis, and this is the Lewis structure. Carbon is in group 4, has 4 valence electrons. 1, 2, 3, 4. So oxygen needs 2 electrons to make an octet. This oxygen also needs 2 electrons to make an octet. So these 2 electrons can be shared with the oxygen. These 2 electrons also can be shared with oxygen. And so you now have the 2 double bonds. So now on carbon, how many non-bonding electrons are on carbon? How many non-bonding electrons are on carbon in CO2? On carbon, 0, correct. So oxygen has used all these. You count it now. Oxygen originally has 1, 2, 3, 4, and is also sharing 1, 2, 3, 4. So carbon is having 8 electrons now, but the 8 electrons are fully bonded. How many valence electrons are non-bonding electrons are in the molecule, on the 2 oxygen atoms? 4 pairs, not 2, 4 pairs. 1, 2, 3, 4. But carbon has nothing. But are they all octets? Yes, oxygen is an octet. 1, 2, 3, 4, 5, 6, 7, 8. The second oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. They are all happy. So each of them are, but carbon does not have any non-bonding electron, but the oxygen have 2. So if I want to draw the Lewis structure of this, for example, I can, Okpe Onas, or what is your name? Type your question. Don't raise any hand. If you have any question, you type your question. So for this, for example, now, you now have valence electron 1, 2, bond 3, 4. This also has 1, 2, 3, 4. So there are 4 valence electrons in total. So this has a pair here, another pair here, another pair here. So we have 4 valence electrons in the molecule. And the 4 valence electrons, each oxygen has 2 pairs. Carbon does not have any valence, non-bonding electron. All the electrons have been used to form a bond. So look at the oxygen molecule also. Oxygen has 6 valence electrons. Oxygen has valence. Can we say 8 electrons rather than 4 pairs? Usually, I would rather you write your electron. The electron comes in pairs. So don't say 8 electrons, say 4 pairs of electrons. You can't say you have, you want to wear your glasses. You can't wear one eye of the glasses. A pair of glasses contain 2 lenses. So it is 4 pairs of electrons, not 8 electrons. All right. So let's go back to oxygen now. Oxygen has 6 valence electrons. Each of them have 6. And to distinguish between the 2 oxygen atoms, we put them, you use dots and cross. So these are 6 dots for the electrons. These are 6. So for them to share now, these 2 electrons can be shared. And when the 2 electrons are shared, they will form a double bond. Sir Stevens, yes, we'll get to that later. We'll come to that later. Let's face what we are doing now. You are jumping ahead of the class. So now, when these 2 come together, you can see here now that they can share this electron. So these 2 electrons are shared. And when the 2 electrons are shared, a bond will be formed between them. And that's why you have a bond between the 2 of them. So there's a bond here, there's a bond here. So between the 2 oxygen atoms, there's a double bond. This is the molecular structure. So there's a double bond. And these other electrons are the non-bonding electron pairs. So they are the non-bonding electron pairs, as you can see. We also have an example of ethane, C2H4. You have 2 carbon atoms and 2 hydrogen atoms. This carbon atom has 4. This other carbon also has 4. And you can see these ones can share electrons to give triple bond, and this one electron is shared between to this one to form a bond. This also forms one bond, and these two carbon atoms will share this. So you can see now that the covalency between the two carbon atoms is 3, and the covalency between the carbon and hydrogen atom is 1. So this is how you have your ethine, C2H2. Our time is fast spent. We have to rush and finish on time. Please, can you keep all your questions until after the class so we finish on time? So the triple covalent bond also follows the same thing. They form 3 bonds, and in terms of strength, a triple bond is thrice stronger than a single bond. So a triple bond, the example we've done before is your ethine that has a triple bond between the two carbon atoms. Nitrogen also can have a triple bond between the two nitrogen atoms in the nitrogen molecule. And in terms of the length of bond, as your bond order increases, your bond length decreases. As bond order increases, bond length decreases. As bond order increases, bond length decreases. Note that. So this is the example of the triple covalent. That is your nitrogen. And ammonia is your single covalent bond. This is an example of 4 single bonds in your methane. Each of them sharing 4 hydrogen atoms. Each of them have 1 electron. We share with the 4 valence electrons of carbon to form CH4, and each of them having a single bond, linking them together. And in this case now, does this carbon have a non-bonding electron? In methane, is there a non-bonding pair on carbon? Answer, is there a non-bonding pair on hydrogen? So both hydrogen and carbon in methane, none of them have valence non-bonding electrons. Hydrogen is happy with its duplex, and carbon is happy with its octet. You can see for carbon 1, 2, 3, 4, 5, 6, 7, 8. And for hydrogen, 1, 2, 1, 2, 1, 2, 1, 2. They are happy. No bonding, non-bonding electron in methane. So now in comparing between this, in comparing our, so we want to compare this now. So these are other examples. So you see water, hydrogen chloride. This is water, 2 single bonds. This is ammonia, 3 single bonds. This is methane, 4 single bonds. So this is how they are formed. So to compare the two, so in a triple bond, you have 6 electrons that attract electrons. So a triple bond is strongest, followed by a double bond, then followed by a single bond. So in terms of bond length, you consider that in a triple bond, 6 electrons are attracting electrons towards the nuclei with a great force. So because of the number of electrons are many, the distance of separation is shorter. So the bond length is shorter, but the bond strength is more. So in terms of length, bond length, a triple bond, it has the shortest bond length, followed by a double bond, followed by a single bond. So in terms of bond length, the single bond has the longest length of the bond, while the triple bond has the shortest bond length. So in terms of bond length, triple bond length is shorter than double bond length, and the single bond length has the longest length. So a shorter bond means greater bond strength. And of course, so the energy required to separate the bonded atom, which is bond energy. So the triple bond has the highest energy, while the single bond has the lowest energy. But in terms of bond length, triple bond length has the shortest length, and the single bond length has the longest bond length. So you have to take note of that. So the formation of covalent bond is as a result, is favored by high ionization enthalpy or high ionization energy of the combining elements. and nearly equal electron gain enthalpies or electron affinity. There is equal electronegativities of the combining elements, and there's a high nuclear charge and small atomic size of the combining elements. So coordinate covalent bond, this is where we'll be wrapping up. This is formed when the electron pair that is shared is provided by one of the combining atoms. So this is coordinate covalent. One of the atom is providing the two electrons that is being shared. One atom is providing, and this atom is called the donor atom, while the other one is called the acceptor atom. So this bond is called a dative bond, and it is usually signified by an arrow. And as you can see here, this is an atom. We have atoms X and Y. They want to come together to form a coordinate covalent bond. X has two electrons, and these electrons that we talk about are the non-bonding electrons. Y does not have any electron. So this Y comes the vacant orbital, and it comes together with X and they overlap. So these two electrons that they are sharing is from X. So X is the one giving the donor atom, Y does not have, and they will form a bond between them. So the both electrons will come together, but the bond between them, the electron pair of the bond is donated by only one of them. Unlike the other one, why the two of them will share, only one is bringing electron that they are sharing. And a good example is ammonia. Remember that ammonia has a lone pair of electron. The other electron pairs are already shared with hydrogen. So this lone pair of electron, when it reacts with hydrogen ion, how many electrons does hydrogen ion have? Hydrogen ion, how many electrons does this hydrogen ion, this proton, how many electrons does it have? Type it in the chat box. 0. Good. Hydrogen has only one atom, and when it loses that, it has only one electron, and when it loses that one electron, it becomes positively charged. So hydrogen does not have any electron, and ammonia has a pair that is not using for bond. So when the two of them come together, there will be a bond between them. And here this bond is indicated with an arrow. The arrow pointing towards the atom that is collecting. So now this bond here in ammonium ion, the fourth bond here, so these three bonds are the covalent bonds, the ordinary covalent bonds, while this bond here is the dative covalent bond. And this dative covalent bond is as a result of donation of electron by the lone pair of nitrogen, while nitrogen has nothing to contribute. So that's the difference between the normal covalent bond and the dative covalent bond. And this brings us to the end of this class. So any question? So the slides will be dropped on LMS, and the video recording also will be dropped on LMS. So thank you for attending the class. See you on Friday. Bye.